Good morning all. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about shift micro operations. So what are the shift micro operations? So shift micro operations are used when the data is stored in the registers. These micro operations are used for the serial transmission of data. Here the data bits are shifted from left to right. These micro operations are also combined with arithmetic and logic micro operations and data processing operations. Actually, in the computer organization, it will be accept only binary numbers. Only binary numbers. Those are in the form of zeros and ones. So suppose if I'm taking 8 bit of register, if I'm taking 8 bits of register, so it is the 8 bit register. So this 8 bit register example, shift micro operation means we have to shift these values to the another register. So suppose R1 to R2 or R2 to R1. So what are the values are there in the register? We have to shift those values from another one register to another register. So what are the operand? What is the instruction? What are the micro operations we are performed to shift the registers? Okay. So these micro operations are used in the serial transmission of data. Everything I am taking as a serial. At a time parallel is not possible. So serially we have to take. So this serial transmission of data, the data bits are shifted from left to right. These micro operations are also combined with arithmetic and logic micro operations and data processing operations. So any of the shift micro operation, we need a register to perform. So here we are taking example, any of the example you have to take 8 bit register. So in the 8 bit register, you have to take some binary values. So shift to micro operation means I have to shift the values. So micro operation means it is a process. So what is a process I'm using? That is a shift to micro operations. So these shift to micro operations are using with instructions. We are performing with instructions. So we are performing instruction with the micro operation for the data transmission in the serial transmission of the data. Shift left or shift right micro operation. So shift micro operations are used for serial transfer of data. The contents of a register can be shifted to the left to right. During a shift left operation, the serial input transfer a bit into the rightmost position. During a shift right operation, the serial input transfer a bit into the leftmost position. There are three types of shift operations are there: logical, circular, and arithmetic. The symbolic notation for the shift micro operations are shown in the table. Shift micro operation means we are shifting the shift data to the one register to another register. So what is the data? It is a binary data. What is the data I'm using means I'm using here binary data in the form of zeros and ones. So these binary data we are shifting from one to another. That is the shift data. So shift micro operations are used for serial data transmission. So parallel it is not possible. So serially we have to do, and the contents of a register can be shifted to the left to right. So suppose I'm taking R1 register to R2. So shift left, I'm using shift left, or R2 to R1, shift right. Okay. So left or right is possible. Shift left or shift right is possible. And during a shift left operation, the serial input transfer a bit into the rightmost position. So I'm taking shift left means it is from shift left. That means suppose here it is R2 and it is R1. So shift left means right to left or not? Yes, it is a right to left. So when I am performing the shift left operation, the serial input transfer a bit into the rightmost position. Okay, I'm going from right to left, rightmost position. And during a shift right micro operation, shift right means suppose R1 to R2. So it is a left and it is a right. Left to right, that is a shift right operation. Then what is that means? The position is in the bit position is exactly the left side. And there are three types of shift operations are there. First one logical, second one circular, and third one arithmetic micro operation. The symbolic notation for the shift micro operations are shown below. Here I am taking SHL. It is a SHL, means shift left operation is performing for what? Register R. So register R, in the register R, what is the binary data is there? That binary data I'm shifting to the another register with the shift left operation. Here SHR, that is the shift right operation, and CIL, that is a circular left, CIR, circular right operation, and ASHL means arithmetic shift left, SHR means arithmetic shift right operation. So in the shift operations, logical, circular, and arithmetic. So logical, in the logical two types are there. So shift left logical, shift right, and another is a arithmetic shift operation. Two types are there: shift left and shift right operation. Another is a circular. Circular also two types: shift left, another is a shift right. So totally 1, 2, 3, 4, 5, 6 are performing with logical, arithmetic, and circular. So these are the shift operations are performing. So SHL means shift left of the register R. SHR means shift right of the register R. CIL means shift circular, shift left of the register R. CIR means circular, shift right of the register R. And ASHR, arithmetic shift left register, and ASHR, arithmetic shift right of the operation. So these are the total 6 operations are performing. So majorly defining 3, but including subtopics, we have to go for the 6 shift operations are performing. So these are the shift micro operations. So first one, logical shift micro operation. First one is a logical shift operation. What is the subtopic here? There are two types are there: shift left and shift right operation is performing. In the arithmetic shift operation, two types: arithmetic shift left, arithmetic shift right. In the circular shift operation, two types are there. What are that means? Circular shift left, another is a circular shift right operation. So logical shift micro operation. In the logical shift micro operation, moves the 0 through the serial input. There are two ways to implement the logical shift: logical shift left and logical shift right. So logical are two types are there: logical shift left, logical shift right. So the logical shift operations are moves to the 0 through the serial input, and there are two ways to implement: logical shift left and logical shift right. So logical shift left, in this, each bit in the register is shifted to the left one by one in the shift micro operation, and the most significant bit is moved outside the register, and the place of the least significant bit is filled with 0. So example, here I am taking 8 bit of data, that is 0 0 0 0 1 0 1 0, and when we perform a logical shift operation, all these bits will be shifted towards the left, and the MSB or the leftmost bit, that is 0, will be moved outside and at the rightmost place of LSB. 0 will be inserted as shown below. So in the logical shift left, what are the conditions are there? In that means every register shift left one by one only possible. That is a serial. That is a serial communication, not a parallel. Not a parallel. So the most significant bit is moved outside the register and the place of the least significant bit is filled with 0. So LSB is filled with 0 and MSB is shifted to what are the new registers it will be shifted, and the logical shift left of the these bits are will be shifted towards the left, and the MSB of the leftmost bit, that is 0, will be moved outside and the rightmost bit LSB 0 will be inserted into the below. So it is a process of shift left operation. So here I am taking one example. Already we discussed here. What is example? 00001010. So 00001010. Okay, it is the before shift operation. So what is the process? To implement the logical shift left micro operation, SHL R1 tends to R1 means shift left. What are the R1 values are there? Those R1 values are after the shift left, those are replacing with R1. This command means the 8-bit presence in the R1 register will be logically shifted left and the result will be stored in the register R1. So R1 values are storing again in the R1, but what is the condition means I'm applying shift left operation. Moreover, the logical shift left micro operations denote the multiplication of 2. So multiplication of 2 means suppose input I am giving some 35. Example I am giving 35 value. So multiplication of 2 means output will be 70. Suppose this value is 35. So multiplication of this means 70. So output I am getting the 70. Before the shift left, what is the value of decimal value is there? After this, we are multiplying the 2 times will be increasing. 35 into 2 means 70. The value will be 70. Moreover, the logical shift left micro operations denotes the multiplication of 2. It is converting into the decimal form of the number 10, and the result after logical shift left operations when converting to the decimal forms of number 20. So here I am taking shift left operation. 1, 2, 3, 4, 5, 6, 7. Only 7 bits are transferred. So what is the remaining means? Here it will be empty. So this MSB is filled with LSB. Okay. So what is the process is going on? Right to left, right to left. So shift left is performing. So shift right. Shift right is shifted to the right one by one in this shift micro operation. The least significant bit is moved outside the register and the place of the most significant bit MSB is filled with 0. And in the 8-bit, it is a value is this one. And to perform logical shift right on these bits, it will be shifted towards the right. The LSB on the rightmost bit, that is 1, will be moved outside and the leftmost place MSB 0 will be inserted as shown. So here I am taking shift right operation with register R1, SHR R1 tends to R1 means after the shift right, the R1 value is shifting to the R1 register. So how it is possible means shift right means right to left to right. The performance going on from left to right. That is from MSB to LSB. So the LSB of the rightmost that one will be moved outside to the leftmost place. MSB 0 will be restored in this below. So here I am taking it is a right and it is a left to right. Left to right means shift right operation is performing. Okay. So here what is the value here? Here 1 is filled. Okay. This 1 is shifted. So after the new value, what is this? It is an empty now. So empty is filled with 0. Arithmetic shift micro operations. The arithmetic shift micro operations moves the signed binary number either to the left to the right. There are or right to the left. But here arithmetic means two are there, shift to the right or, or shift left. There are two implementations of arithmetic: arithmetic shift left, arithmetic right. So there are two types are there. Arithmetic shift left micro operation is the same as a logical shift left, but in this register we are shifted to the left one by one to the shift micro operation. The most significant bit MSB moved outside the register and the LSB is filled with 0. Here I am taking one example. So we are performing arithmetic shift left on this will be shifted towards the left, and the MSB or the left bit is 0 will be outside and the LSB 0 will be filled. So here I am taking one example. It is a 35. This binary value in the decimal value is 35 in the decimal system, and the binary after logical shift left it represents 70. That is a 35 into 2. The value will be given to 70. Then we can arithmetic shift multiplying by 2. Okay, multiplying by 2 means shift left. Shift left we are multiplying. Shift R means we are dividing. Yeah, dividing. So arithmetic shift left R1 tends to R1. So this command means that 8-bit represents the R1 register will be arithmetic shift left, and the result will be stored in register R1. So you are taking all those things here. So what is the final value here? 0. So this is filled with 0. So before shifting process, the value is 35. After shifting, value is 70 based on 35 based. Okay, it is 2 times will be increased compared to with the input value. So arithmetic shift right, each bit in the register is shifted to the right one by one, and the LSB is moved outside the register, and the place of the most significant bit is filled with the previous value of MSB. So MSB filled with the LSB is filled with the previous value of MSB. Here I am taking one example: 101000011. We have to perform an arithmetic shift right on these bits. All these bits will be shifted towards the right. The LSB or the rightmost bit that will be moved outside at the leftmost place MSB. The previous MSB value equal to 1 will be inserted as shown in the below. So here arithmetic shift is divided with by 2. He previously we discussed multiply, here dividing. Arithmetic shift left means multiply with 2. Here dividing by 2. So arithmetic shift right is dividing by 2. R1 tends to arithmetic shift right means after the arithmetic shift operation of R1, the final data is stored in R1. This command means 8-bit represents in the R1 register will be arithmetic shifted right, and the result will be stored in the register R1. Okay, here I am performing left to right, means arithmetic shift right is performing. So what is the MSB value? Here already is this one is there. This LSB is replaced with MSB. What is MSB value here? It is replaced with MSB. The least significant is moved outside the register, and the place of the MSB is filled with the previous value of MSB. So the previous value of MSB is filled with LSB. So circular shift micro operation. The circular shift, also known as the rotate shift, moves bits into the register sequence around both ends, thus ensuring no loss of information. There are 2 ways to implement the circular shift. Circular shift left, circular shift right operation is there. So in the circular shift register, each bit in the register is shifted to the left one by one onto the shift micro operation. After shifting, the least significant bit place becomes empty. So it is filled with value at the most significant bit MSB, and we have to take one input is a 000101000. It is a 8-bit value, and we can performing with a circular shift left on these bits. All the bits will be shifted towards the left. The MSB or the leftmost bit is 0 will be placed at the rightmost place of the LSB as shown. So each of the register is shifted left of register. After shifting, the LSB becomes empty, so it is filled with value of the most significant bit. And the below data 8-bit, when the we perform circular shift left, the bits, all the bits will be shifted towards the left. So right to left is shifting. The MSB or the leftmost bit, leftmost bit or MS, it is MSB and it is LSB, is replaced with rightmost place of the LSB value. To implement the circular shift left operation, we use the circular shift left CIL symbol, and R1 tends to CIL R1. So R1 of the register values of data is applying shift left, circular shift left, converting to the R1. The resultant of circular shift left operation, the final binary values are shifted to the R1. This command means that 8-bit represents the R1 register will be circular shifted left, and the result will be stored in the register. So here LSB and MSB. So I am performing right, left. Okay, it is shift left operation is performing. SHL shift left performing, and final MSB. What is the MSB value? It is replacing with LSB. So the value of MSB, of the final value MSB, is to replacing with LSB. So that is important. And the circle shift right is shifted to the right one by one in the shift micro operation. After shifting, the most significant bit place becomes empty. So it is filled with the value at the least significant bit LSB. For example, I am taking below data. There are 8 bits are there. That is 000, 10, 100. When we perform a circular shift right on these bits, all these bits will be shifted towards the right. The LSB or the leftmost bit, that is 0, will be placed at the rightmost of the MSB. To implement this circular shift right operation, we use CIR, means circular symbol, CIR. CIR R1, circular shift right. CIR means circular shift right. So CIR R1 replacing with R1 register. This command means 8-bit presents the R1 register will be circular, shifted right, and the result will be stored in R1 register. Okay, it is a LSB and MSB. So it is a left and right. Shift left means left to right is performing. So what is the LSB value? That is replaced with MSB. Previously MSB is replaced with LSB. Now LSB value replacing with MSB. And these are the references of this one. So these shift micro operations are used in the data storing of the registers, and we are using in the micro operations are used for the serial transmission of data, and the data bits are shifted from left to right. These micro operations are combined with arithmetic, logic operations, and data processing. So we are converting data, shifting data. So it is a data transfer from data transfer from one register to another register, R1 to R2 or R2 to R1. So what is the data here means? The data is nothing but a binary data. The data is nothing but a binary data. So binary data means in the form of ones and zeros are there. So shift micro operations are performed here to shifting the data from one register to another. There are 3 types are there: logical, circular, and arithmetic are there. So we are shifting with micro operation with through the instructions. So it is a symbol designation and a description. Shift left register SHL, shift right SHR, and circular shift left CAL, and circular shift right CAR, arithmetic shift left ASHL, and arithmetic shift right ASHR. Okay, these are the symbol designation with description of shift micro operations. So logical shift micro operations are 2 types: logical shift left, logical shift right. Arithmetic shift micro operations means arithmetic shift left, arithmetic shift right. Circular means circular shift left and circular shift right. Total 6 types are there. What majorly dividing as a logical, arithmetic, and circular operations. So logical shift operations are 2 times: logical shift left, logical shift right. So these logical shift micro operations moves the 0 through the serial input. There are two ways to implement. And logical shift left means SHL, shift left. SHR is a shift right. So each bit in the register is shifted to the left one by one onto this shift back operation. The most significant bit MSB is moved outside the register, and the place of the least significant bit LSB is filled with 0. So the data 8 bit is displaying here 00001010. It is the input value. We are performing shift left to this one. So after the shift left, what is the final value? We have to find out. And the logical shift left on these bits are the shift towards the left. The most significant bit of the leftmost bit, that is 0, will be moved outside, and at the rightmost place LSB 0 will be inserted. And to implement the logical shift left micro operation, we use SHL, shift left of the register R1, replacing with R1. These commands means 8 bits represent the R1 register logically, and moreover the logical shift left operations denotes the multiplication of 2, and we have to take an above when converting into decimal forms the number equal 10, and the resultant after the logical shift operations when converting to the decimal forms of the number 20. It is one example. So shift right means the register shifted to the right one by one at the shift micro operation. The LSB is moved outside the register, and the place of the most significant bit is filled with 0. Here I am taking one example of 8-bit value. It is a logical shift operation is performing, and the LSB or the rightmost bit, that is 1, will be moved, and the leftmost MSB 0 will be inserted as shown in the below. So here I am taking SHR shift right operation is performing. So here, what is the empty value of the new R1? It is replaced with value 0. And arithmetic shift means when we are performing arithmetic operations, then only we have to use these arithmetic shift operations. Signed binary number either left to the right or right to the left. So there are two types are there: arithmetic shift left and arithmetic shift right operation is performing. So arithmetic shift left, the arithmetic shift left micro operation is the same as a logical shift left micro operation. Each bit in the register is shifted to the left one by one into the shift micro operation. So we are shifting data to the one register to another. So the most significant bit MSB is moved outside the register, and the place of the least significant bit LSB is filled with 0. So I am taking one example of 00100011. Is it 8 bit? It is 8 bit. 1, 2, 3, 4, 5, 6, 7, 8. And to perform the arithmetic shift left on these bits, all these bits will be shifted towards the left, and the MSB of the left bit, that is 0, will be moved outside at the rightmost place LSB, and 0 will be inserted to the shown below value. Here I am taking 00100011. Okay, this represents the 35 value in the decimal system. But what is the final value of output is a 70. Why? Because 35 is double 2 times, means multiplying with 2, then I will get the 70. So before shifting process 35, after the shifting value, the value is 70 wasted. So it is a arithmetic shift right operation is performing. Arithmetic shift right means we are shifting right all those things. And what is the final MSB value is there? It is taking as is. Okay, MSB value is copying like this only. So when I am going to the left, it is also copying this LSB as is. Okay, so here MSB value is replaced with LSB. Okay, it is a shift left right operation. This one is copying like this. Shift right operation. And another one is a circular shift left. Each bit is shifted to the left one by one into the shift operation. After the shifting, at least significant bit LSB placed becomes empty. So it is filled with the value at the most significant bit MSB, and the input value, example taking 00010 100. This is the before shifting process. Before shifting operation of R1, after shifting operation of R2. So before shifting, what is the value of R1? After shifting, what is the value of R1? So it is the before shifting R1. So here 00010 100. But here after shifting, both are same? No. 0010 So these are the values are changed. Why? Because we are applied here shift left or shift right operation. So here circular shift right and circular shift left operation is there. In the circular shift right, the register values are shifting from right to the left. So left to right, it is a left and right. Left to right is performing, and the MSB placed becomes empty. So it is filled with the value of least significant value LSB, and it is an example I'm taking. And we can perform circular shift right on these bits. All these bits will be shifted towards the right, and the LSB or the leftmost bit, these will be placed at the rightmost of the MSB. So here left side is LSB and right side is, here I'm taking left and right. Here it I'm taking MSB. Here right is the LSB. Okay. So here shift right means MSB to LSB. Here most significant bit is becomes empty. So it is filled with value of LSB, and LSB or the leftmost bit LSB 0 will be placed with the right place of the MSB. This LSB value is replacing with MSB. Okay, CIR means circular right of the R1 register is shifting to the R1 after the circular shift left operation, or here R means right, circular shift right operation. This command means 8-bit represents the R1 register, will shifted to the right at the result will be stored in the register R1. Okay, here from MSB to LSB, that is from left to right. So here it is a empty value is there. This LSB value is replacing with MSB. Okay, it is about the shift micro operations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.